All right. So hopefully we're going to be finishing this note sheet up today. We're going to be doing this here. And a good bit of this one and the last few are triangle based. And most all of this is formula based. Most everything we're doing in this is all based off the formulas, finding it, using it, simplifying it in some way, shape, or form. So we want to write this as an algebraic expression. Sine of arctangent of 1 plus arc cosine of x. So this is our sine sum identity, sine of alpha plus beta. So it'd be sine of alpha cosine beta plus cosine alpha sine of beta. And in our case, this is really our alpha, this is our beta, because arc cotangent would give us an angle, arc cosine would give us an angle. Now in both cases, at least with arctangent, we could actually get a value because it's arctangent of 1, which is really telling us tangent of alpha is 1, and the only case that works out is with pi over 4. But we're going to use a triangle to get there. And tangent is opposite over adjacent. We'll say this is our alpha. So tangent of this is the opposite side, which is 1. Over the adjacent side, well, it didn't give us a denominator specifically, but the denominator is also understood to be 1. Because when the denominator is not given, it's understood to be 1. I'm going to use Pythagorean's theorem. I'm going to make a new slide just so that we can write this out and it doesn't get too messy on the previous slide. Our two sides are both 1, and we're trying to find the hypotenuse. So 1 squared plus 1 squared, 1 plus 1, so 2 is equal to c squared. Take the square root of both sides. Our hypotenuse is the square root of 2. We don't use the plus or minus because we're talking about the hypotenuse, which is always positive. So we get square root of 2. So for our alpha, the triangle is set up this way, 1, 1, square root 2. For our beta, arc cosine, which is really telling us this is cosine of x. Cosine of beta is equal to x. Cosine is adjacent over the hypotenuse. Since they didn't give us the hypotenuse directly, it's 1, because it's x over 1. So this time they did give us one of the a and b values, and then they gave us c. So we could set a or b, doesn't matter which, as x. We're going to solve for the other. Now x squared, well, is x squared, plus b squared is equal to 1. At this point we can subtract x squared from both sides, telling us b squared is equal to 1 minus x squared. Square root both sides, b is equal to the square root of 1 minus x squared. We get this here, which tells us the other side is the square root of 1 minus x squared. Now for us here, we're going to keep it as the positive case. We're not going to worry about this being a negative angle or this angle being in the second quadrant. We're going to focus on the first quadrant. So we have these here. Questions on this so far? Now at this point, we can solve the rest of this here, because this whole statement, sine of alpha times cosine of beta plus cosine alpha Sine of beta is just straight formula. Now, sine of alpha, we have our triangle over here. Opposite over the hypotenuse would be 1 over square root 2. Cosine of beta, x over 1, or just x. And that kind of makes sense because if we did cosine of arc cosine of x, we just get x. Plus cosine of alpha, adjacent over the hypotenuse, 1 over the square root of 2. Sine of beta. Well, sine is the opposite side, which is our 1 minus x squared, over the hypotenuse, which is 1. Questions on this here? So it's all based off these triangles, and a lot of this in the last few that we did, or the ones we ended yesterday with, is really we set the triangles up, we use the triangles. Now at this point here we multiply together, so we'll get x over square root of 2 plus square root of 1 minus x squared over the square root of 2. Now since the denominators are already the same, they're both square root of 2, we can just add the numerators. But since x and the square root of 1 minus x squared are not like terms, it just becomes x plus the square root of 1 minus x squared. Something, at least in me, sometimes is just you get this feeling that I should be able to reduce the square root of 1 minus x squared, but we can't, because we can't turn it into a single term squared. So we have to leave it as that. Because if we did try to factor it, it would be 1 plus x times 1 minus x, not a set of parentheses squared. It doesn't simplify. So we get this here. Now the only thing that we have left is to rationalize this denominator. And as I said yesterday, we haven't actually gone through the process of it. We've let the calculator do it for the most part. And for these here, it's just multiplying the top and bottom of this fraction by something that will make the square root of 2 square root simplify. And then since it's just a square root, we multiply it by itself. Square root of 2 times square root of 2, it's just 2. Square root of 2 times x is x square root of 2 plus. Now if you do reference back to the book I believe puts this as square root of 2x. They put the x after the radical. I don't like putting it there just because it has a tendency to slip inside the radical if we're not paying attention. So I leave it in front. When we multiply the square root of 2 by the square root of 1 minus x squared, we can actually multiply the 2 through what's inside the radical. So we get 2 minus 2x squared. And that'll be the final answer. Questions on this here? Questions on anything we've done so far? Feel good with this here, for the most part anyways. All right, we're not going to worry about proofs because all this is just using the cosine identity to show that it is sine of x. We're not going to worry about that. Express as a trig function of only theta. So we want our final answer to only be in terms of theta with cosine. We don't want an actual angle in there. So if we look at this here, cosine of theta minus 3 pi over 2. Let's borrow this. So we're looking for our difference, which is on the front of the second page. So this here, the same as our cosine of alpha, cosine beta, plus sine alpha, sine beta. Where the first angle is alpha, second one is beta. I think I used alpha beta for all of those. Almost. think you were looking at product to sum, sum to product. So here, alpha is theta. So we would say cosine of theta. Cosine, well, our beta is 3 pi over 2. Plus sine of theta, sine of 3 pi over 2. Give you all a second to write that down. Now, out of these here, cosine of 3 pi over 2 actually has a value, which is 0. Sine of 3 pi over 2 has a value, which is -1. Both of these are on the unit circle. We could use it or the graphing calculator or the 30xs. Either one of them, as long as we have them in radians, will give us an answer. Well, cosine times 0 is 0. And sine of theta times -1. We have now expressed this as a trig function only in terms of theta. We're done. Expressed as a trig function in only terms of theta. Well, tangent, if we add two angles together, I believe is going to be tangent of alpha plus tangent of beta over 1 minus tangent of alpha, tangent of beta. So we'll look on the first sheet. It had to be subtracted, so we flip the page. On the front, yes, right there at the very bottom. So if we plug in our values, alpha is going to be theta. Beta is going to be 3 pi. So in the numerator, we still have tangent of theta plus tangent of 3 pi incidentally is 0. Now 3 pi is technically on the unit circle, because if we go all the way around, we get 2 pi. But we got to go one more. So we're actually over at pi. 3 pi and pi are the same angle. And at pi, sine is 0, cosine is -1. 0 over -1 is 0. So we get 0. In the denominator, we have 1 minus tangent of theta times 0. Which does simplify quite nicely, because the numerator is just going to be tangent of theta. The denominator, well, that's all 0. It's just 1. So we can just say that this is tangent of theta, and we're done. So these here, when we're simplifying it to simplifying it to be our trigonometric functions in terms of theta, use the formula, plug it in, simplify the ones we can actually simplify that have an angle, and reduce where possible. That's it. Questions on this here? I think we feel comfortable with these here, yes? So I'm not going to bore you all with another one. If you do have questions on them or something tricky comes up, please ask. And I think that brings us to the last step. Yes? I think solve. I could have just looked at the thing. Yep, okay. So last two. Now with solving, find all the solutions for this here on the interval of 0 to 2 pi. Now the first thing we can do, especially with both of these here, is rewrite them with their formulas. So the first one that we're going to rewrite is our sine of x plus pi over 4. This is our sum identity, with alpha being x and beta being pi over 4. So this is sine of alpha, so sine of x, cosine of beta, cosine of pi over 4, plus cosine of alpha, so cosine of x, sine of pi over 4. So that's our first part there. Now, since there's not a sign in front of it, it's going to be positive. We don't necessarily have to put parentheses around it. Plus in the middle, we don't necessarily have to put the parentheses around the other one because the signs aren't going to be altered. We'll do the same thing, but this time with our difference. So sine of alpha would be sine of x. Cosine of beta would be cosine of pi over 4. Minus cosine of alpha, so cosine of x. Sine of beta, so sine of pi over 4. And this is all equal to -1. Well, this went from being a medium-sized equation to a pretty big one. Also, this pen makes, I can't write smaller than this, so it always looks a little bigger than it actually is. Questions on how we got to this here? Now, if there is a subtraction, we're subtracting the two, I would put them in parentheses because of the distributive property of that negative. Now, the next thing we would do is simplify what we can. Well, cosine of pi over 4 and sine of pi over 4 actually have a value, yes? Which is square root 2 over 2. So the first one here, really we're saying that we have sine of x times square root 2 over 2, plus cosine of x times the square root 2 over 2, plus sine of x times square root 2 over 2. Well, might be helpful if I actually wrote sine of x times square root 2 over 2 minus cosine of x times square root 2 over 2 equals -1. Now we would have to be careful if we were outside of the first quadrant, because then the signs with that would be a little different, because positive negatives with sine and cosine. But again, unit circle will tell us exactly what it is with its sign. So out of all this here, well, the first one, we have square root 2 over 2 sine of x here. Here, we also have square root 2 over 2 sine of x. Those are like terms. We will combine them in a second, which leaves our other two. This one here is square root 2 over 2 cosine of x. And our last one is negative square root 2 over 2 cosine of x is equal to -1. Now, out of all of our like terms, the cosines are nicer because they become what? So square root 2 over 2 cosine of x minus square root 2 over 2 cosine of x is 0. That whole thing becomes 0. It's gone. The first two do both have sine of x. But now it's really seeing what is square root 2 over 2 plus square root 2 over 2. And we could do that in a calculator. Square root 2. Okay, let's try this one more time. Square root 2 over 2 plus square root 2 over 2 is square root of 2. Because we're really doing 1/2 plus 1/2. So out of all that, it tells us that square root 2 sine of x equals -1. Well, this is almost taking us back to the first lesson. Just divide and solve, yes? Now I'm not going to rewrite it as -1 over square root of 2. Yes, I know. Because we can plug it in. And it does rationalize the negative square root 2 over 2. Now at this point here, there are different ways we could go about getting there. One of them is using arc sine, sine inverse, plugging into the calculator and seeing what we get. But square root 2 over 2 is on the unit circle. And we're looking for the y coordinate of the two pairs where it's negative. And the first spot where it's negative is 5 pi over 4. The other one where it's negative is 7 pi over 4. And those are our two values, and that's it. Questions on this here? Notice a lot the first day back, but we want to see one more. No. So any questions on how we did this? Does this make sense for the most part? Somewhat. I'm going to go on and do this just in case. If you want to follow, follow along if you can't. Not if you can. Follow along if you want. If not, that's fine. I'm going to go on and do it anyways. So if you want to come back to it, you can, and look back at it. Because if we want to find all the solutions for this here, again, we're going to use the same formulas. So the first one's our sine sum formula, the sum identity. So it'd be sine of alpha, which is our first value, x, cosine of beta, which is cosine of pi over 2, plus cosine of alpha, which would be cosine of x, sine of beta. Now they were nice to us again, and they gave us plus instead of minus. And we do the same type formula, sine of alpha, cosine of beta. But it's a difference formula, so we use the other one. And we get this here. So we used the two formulas and plugged in alpha, beta. For the first one, alpha was x, beta is pi over 2. Second one, alpha is still x, beta is 3 pi over 2. Now for the most part for these here, for the ones we'll do, especially on the test, and the homework, the angle that they're going to give us is going to be on the unit circle, because otherwise we're going to have to use the graphing calculator to approximate solutions, because they're going to get not nice very quickly. And if we use the unit circle, cosine of pi over 2 straight up is 0, plus cosine of x. Sine of pi over 2 is 1. Plus sine of x. Well, this time they didn't give us pi over 2, they gave us 3 pi over 2, which incidentally actually is straight down, which is 0, minus cosine of x. Well, sine of 3 pi over 2 is negative 1. Well, it's kind of nice because that's 0. That's 0. And we have cosine of x plus cosine of x equals 1, because our negative cosine of x times negative 1 makes it positive. And cosine of x plus cosine of x is 2. Cosine of x is equal to 1. At this point here, we would divide both sides by 2. Telling us cosine of x is equal to 1/2. At this point here, we'll reference back to the unit circle. And since it told us it's between 0 and 2 pi, we don't have to look more than once around the unit circle. So pi over 3, or 5 pi over 3. And that's it. Incidentally, that is it.